When you look at a finished building, it's easy to see it as a single, complete object. But for those of us in construction, we see the layers, the carefully sequenced assembly of parts that make it stand up, keep the weather out, and make it functional for people. So, what are these fundamental parts? What is the actual anatomy of a building? Whether it's a simple shed or a 100-story tower, all buildings share the same basic components, each with a critical job to do. In this video, we're going to dissect a building from the ground up. We'll start with the hidden parts buried in the earth and work our way to the roof, explaining the role of each component and how they all work together as a single, integrated system. By the end, you'll be able to look at any structure and understand not just what you're seeing, but why it's there. Let's start at the very bottom, with the part of the building you never see but is absolutely critical, the substructure. This is the part of the building below ground level, and its primary job is to transfer all the loads from the building safely into the earth. The main components here are the foundation and the footings. The footings are the widened, typically concrete elements at the base of foundations that spread the concentrated load from columns and walls over a larger area of soil. This prevents excessive settlement. The foundation itself can be a deep system using piles or caissons that go down to a stable soil layer, or a shallow system like spread footings or a raft mat. A pro tip from geotechnical engineers is that the foundation design is 100% dependent on the soil report. Building on the wrong foundation for the soil type is one of the most costly and dangerous mistakes you can make. The substructure also includes the plinth, the portion of the wall between the ground level and the finished floor level, which acts as a barrier against moisture and pests. Now, let's move above ground to the superstructure. This is the part of the building that sits on the substructure and constitutes the main usable area. The primary components are the floors, walls, and roof. Floors are the horizontal elements that divide the building into stories. They consist of a structural slab of concrete, steel deck, or wood that carries live and dead loads, and a finishing layer. Walls are the vertical elements. We have load-bearing walls that carry loads to the foundation, and non-load-bearing partition walls that just divide space. The exterior walls form the building envelope. Finally, the roof is the uppermost part, the building's umbrella, consisting of a structural system and a waterproofing layer. The efficient workflow secret is that the superstructure is built in a precise sequence, vertical elements first, then horizontal elements, and repeat. A building is more than just a structural skeleton. It needs systems to make it livable. This is where the building services or MEP systems come in. These are the nervous and circulatory systems of the building. M stands for mechanical HVAC, heating, ventilation, and air conditioning, which controls temperature and air quality. E is for electrical, which includes wiring, lighting, and power. P is for plumbing, which brings in fresh water and removes waste. A common and costly drafting mistake is poor coordination between architectural and MEP drawings, leading to conflicts where a pipe must run through a critical beam. A pro tip is to use BIM for 3D coordination to clash detect these issues before construction. The final layer is the finishes and interiors. These are the components we touch and see daily, defining the aesthetic and functional quality of the space. This includes floor finishes like tiles or wood, wall finishes like paint or paneling, and ceiling finishes. It also includes fixtures and fittings like kitchens, bathrooms, and doors. While often non-structural, their selection is crucial for durability, maintenance, and user experience. A building with a perfect structure but poor finishes will feel cheap and fail over time. We also can't forget special components like stairs and lifts for vertical circulation. And the building envelope itself, a system that includes the weather barrier, air barrier, thermal insulation, and exterior cladding, all working together to protect the interior from the elements. To summarize the key takeaways: 1. The substructure foundation transfers all loads to the ground and is the most critical for stability. 2. The superstructure floors, walls, roof creates the building's form and usable space. 3. Building services MEP make a building functional and comfortable. And 4. Finishes and interiors provide the final aesthetic, durability, and usability. Now I want to hear from you. In the comments below, which building component do you think is the most challenging to design or build? Is it the foundation on difficult soil, coordinating MEP systems, or selecting the right finishes? Your experience helps us all learn. If this anatomy lesson was helpful, please give this video a like and subscribe.